Hello, class 8. Today's topic is conversion of potential energy to kinetic energy. We've seen that energy has so many different forms: mechanical energy, electrical energy, sound energy, light energy, heat energy, solar energy, so many other various forms. Okay, and we've also seen that one form of energy can be converted to the other. We've seen that mechanical energy has two forms: kinetic energy, potential energy. Now we've seen that potential energy can be of two kinds. One was elastic potential energy. I'm writing P dot E for potential energy. You have to write in full, don't forget. Okay, and the other is gravitational, and the other is gravitational potential energy. And for gravitational potential energy, we learned that the expression, this means mgh, gravitational potential. The expression for gravitational potential energy is mgh, where m is the mass of the body, g is the acceleration due to gravity, and h is the height of the body from the ground. You don't need to remember an expression for elastic potential energy. Alright? And the other form of mechanical energy is kinetic energy, and the expression for kinetic energy is half mv squared. Now we've learned that any moving body, all right, the body will obviously have some mass m. Okay, so any moving body will possess kinetic energy, and the expression for kinetic energy is half mv squared, where v is the velocity or speed of the body. Okay, and potential energy, it has two forms: elastic, gravitational. All right, what was elastic potential energy? Elastic potential energy was the energy stored in a body when it is either stretched or compressed. That is, when we bring about a change in shape of the body, the energy that gets stored in the body then is your elastic potential energy. In order, like this rubber band, in order to stretch it, I have to do some work to stretch it. I'm applying a force and producing a displacement on this body, so I'm doing some work. Now the work that I'm doing is stored in this body as elastic potential energy. All right, likewise, I have a spring, I stretch a spring, I compress a spring. I am doing work to compress or to stretch the spring. So whatever work I do to compress or stretch the spring is stored in the body as elastic potential energy. And what was gravitational potential energy? Gravitational potential energy was the energy possessed by a body or stored in a body due to its position. Position meaning its height from the ground. You can see from this expression itself, higher the value of h, more will be the potential energy, more will be the gravitational potential energy. Alright, so higher I take a body up from the ground, more will be the gravitational potential energy stored in the body. Because in order to take the body higher up, I have to do work. Alright, if there's something heavy that I need to lift, okay, I need to do work to lift it up. So whatever work I do to lift the body up, however smaller body be or however bigger body that it be, so I need to do work to lift that body up. And whenever I go on increasing its height from the ground, the work that I do is stored in the body as potential energy. So therefore, higher I take a body, more becomes its potential energy. That is gravitational potential energy, to be more specific, remember. Alright, so here today, like I said earlier, we are going to look at conversion of potential energy to kinetic energy. Like all forms of energy, potential energy can be converted to kinetic energy. Like, again, let us give the example of this rubber band. Okay, I have this small piece of chalk. So I stretch the rubber band. Come on, I stretch the rubber band. Alright, and we will see what happens to this piece of chalk. And there your piece of chalk goes. Okay, I also have made a handmade bow, and we have this not handmade. Okay, we have this arrow. Okay, so when I pull this bow, all right, what happens? its shape is changing, so therefore its elastic potential energy is changing. So when I let it go, there our bow goes. Alright, so what happened? Our elastic potential energy got converted to kinetic energy. Same thing happens in case of a catapult. Alright. Also, if you have a spring, okay, this example, I don't have a spring right now to demonstrate it to you. Alright, if we have a spring, you take a plastic ball, already compress the spring, place the plastic ball on top of the spring and let the spring go. What happens? The ball also flies off. Why? Because elastic potential energy that is stored in the spring due to change in its shape, due to it being compressed, alright, that potential energy gets converted to kinetic energy because the ball starts moving. Okay, so likewise, we have, say for example, water in a tank, and the tank is placed at a certain height. Okay, so if we topple that tank up, all right, if we push the tank, what happens? It falls down. So the water falling from a greater height comes with a greater speed and has a greater impact if it hits us, for example. Okay, we'll blown away by that water. Alright, why? Because higher the tank is and higher the water in the tank is, more its gravitational potential energy. So when the water falls from the tank, okay, so what happens? The high amount of gravitational potential energy is converted to kinetic energy, and that kinetic energy of water sweeps us away. Okay, so we can give so many other examples of potential energy getting converted to kinetic energy. The other thing that we need to look at in this video, class 8, is power, denoted by a capital P. How much is the power, or what is the power? Alright? So, power is defined as the rate of doing work. Rate of doing work meaning how much work can you do in a certain amount of time. Like I have two persons A and B. A can do larger amount of work or more work in 1 hour than B can do. In the same 1 hour, B can do lesser amount of work. So, who has more power? A obviously has more power. Whoever can do more work in a certain time, that person has more power. That is why we say if W is the amount of work done in time T, then power is work upon time. So work upon time is what is read as rate of doing work. This means how much work are you doing in a certain time. That is what is called power. Now the unit of power is, unit of work, let's see, first is joule, and the unit of time is second. So the unit of power is joule per second. Now joule per second is what is called watt. It's not watt, okay, it's watt, W-A-T-T, denoted by a capital W. And 1 watt means 1 joule divided by 1 second. Joule per second is what is called watt, remember. The other unit is kilowatt. Kilo means 1000, so therefore 1 kilowatt is 1000 watts. There is another unit also, the third unit, so to say. It's called megawatt. It's not megawatt, okay? It's megawatt, denoted by a capital M, capital W, and 1 megawatt. Let me write it over here itself. Is 1 with 6 zeros, 3, 4, 5, 6. This many watts. Okay, so to say 10 lakh watts is what is called 1 megawatt. You can also write this as 10 to the power 6 watts. So 1 megawatt means 10 to the power 6 watts.